So I've been reading this book about Hadrian's Wall, and Hadrian's Wall was a wall that was built during the time of the Roman Empire. And it's a real interesting bit of history because not only did the wall stretch for about, I think, 80 Roman miles, which a Roman mile is not the direct equivalent of a mile um, that we know today, but we have uncovered a lot of different sites across the wall, and each site is a little bit different than the next. There was a lot of turrets on the wall. There was a lot of what we would call kind of castles, like structures that resembled some kind of enclosed space that housed either living quarters, and various things like that. But one thing that was uncovered was a tablet, and on the tablet was a bit of writing, and this was actually one of the earliest written tablets from a female. And this is interesting because, well, one, it's on a obviously a stone tablet, which is kind of neat because it's so foreign to us thinking that people used to etch, writing onto a tablet. But it's unique also because the contents of this writing was actually a an invitation to basically a birthday party in antiquity, which is very fascinating. So the earliest written, uh, one of the earliest written tablets from a female from the time of the ancient Roman Empire was an invitation to a birthday party. So what I get from that is never take yourself too seriously because we're all just trying to get by, and there's a lot of funny things that happen in life, just like there is in software development. So that's what we're going to talk about now. And on a more on a more serious note, because how in the world do we transition from Hadrian's Wall to software development? Here's how. Hadrian's Wall is a lot like software development in the sense that, when we build a system, each part of the system built at a different time is probably going to be a little bit different. There's going to be different decisions, different technological choices that we've made at this one part that's not going to resemble a part of the system over there that was maybe built 10, 15 years later that's kind of, been attached on like the wall was. And so the wall, when you have one area where it was living quarters, you may have a little bit down the road, some, a few Roman miles down the wall, you may have what resembled a lookout tower, and there might have been some kind of antique archery outpost, maybe even some kind of antiquated version of a crossbow. And the same thing applies for software development. If we have a system now in place, let's say, for example, our two-stroke engine system, where we have a .NET backend, but later on we needed to build something to process all the data that was going through the backend. So we built a Rust microservice that we then tacked on tacked on through the use of a queue, a message broker. And that's no different than how the wall was constructed, in the sense that depending on the area it was built, there might have been different materials, there might have been different building standards, especially as the time the wall was coming to a close. The building standards, they kind of fell off a little bit. They kind of got a little bit loose, for lack of better words. But the wall was still constructed. The wall was still erected. And this is our great temptation. This is the great temptation in software development, is that when you get 80% of the way done, it's almost like the last 20% is some of the most vital, but it feels like it can be some of the most rushed time in development. And this is just, I think, human nature, but it feels like when we get to a close on a project or near a close, sometimes we can rush to the end or rush to the finish line, if you want to use that phrase. And sometimes this works out, but sometimes it might not. If we cut corners, that wall might start to crumble and it might not last, making it hard to dig up because the remnants simply aren't there. And just like a system, just like in software development, if we don't build it to quality, if we don't build it to spec to begin with, we may encounter a harder time later on, because not only do we have to undo the web of code that's kind of just been, stitched together, but we have to figure out how to diagnose the issues. We have to figure out how to read, the logs, if there are any if there are any even to be read. So just like how we dig up these antiquated tablets, these stone carvings, papyrus scrolls, all this random stuff, a lot of it is fragments, right? We're getting fragmented pieces of paper that we then have to go back and either attempt to finish the rest, meaning we have to take it and look for clues in the rest of the scroll, tablet, stone, whatever it may be, to hopefully maybe piece together what was there or what we think may have been there. And the same way with code, if we have a lot of assumptions built into our code that we don't take note of, that we don't document, we have to go back at a later time, or another team has to come back at a later time and attempt to guess what those assumptions are. And that is one of the biggest problems in software development is, you'll hear that one of the biggest, what the joke is that one of the hardest things in, software development is naming things, naming variables. And that's true. And I think that the second hardest thing in software development is documenting your assumptions, because assumptions in the moment don't feel like assumptions a lot of times. It's hard to recognize assumptions. And if we assume that we're always going to know what this number means or why it's significant or what it represents, if we assume that we're always going to remember it, that may hold true for us, but the next team coming in who's going to be reading this code is going to have no knowledge of why that number is significant. Therefore, that assumption has now been lost in translation. It's been lost in time. And uncovering that assumption is as hard sometimes as trying to diagnose an issue in a system, because we have to go back and read the write-up of the original ticket. We have to go back and read conversations, if there are any. We have to look through messages, emails. We have to look through so many just fragmented sources to hopefully come back and arrive at the original, just like people have to do with Hadrian's Wall and archaeological findings that they found along the remnants of this wall, what little remains. But the spots that were built to the highest quality, allowing for, maybe, in the absence of natural disasters or any other cataclysmic events, those are probably still there. And the quality, the ones that were built to quality, provide sometimes the best information of what the surrounding area was like. But there are long gaps in that wall where there's little really knowledge of what was happening or what was on either side of the wall. And similarly in software development, if things aren't documented, if there's no clear connection between, our front end two-stroke application to our back end Rust processor microservice, there's no clear documentation as to what those two services are doing. It's just going to appear to the next person as two disparate microservices that really have no true logical connection. And so then you have to retrace everything to figure out what's happening. And it's a very, very hard problem to tackle. It's a very real thing that happens in software development. And it's hard, and it's very hard to document things, but it's hard to document things well. And that makes sense, right? Because anybody can write something down. But a lot of times it's writing quality documentation is as hard, if not harder, than the original code itself. So as you're going through code, as you're trying to figure out software development, just make sure that you think of Hadrian's Wall. Thank you all for watching. I'll see you in the next one.